here about electromagnetic waves and wave properties. So a car aerial receives radio waves from a radio transmitter. So an aerial is the sort of metal rod that sticks up from the top of a car that you need to make the radio work. A radio transmitter is something that sends out information about what's involved in the radio program itself for your car to pick up and then play the program. So radio waves are transverse waves, part of the electromagnetic spectrum. Sound waves are longitudinal waves, so it was nice of them to tell you that, they don't always. Describe the difference between transverse waves and longitudinal waves. So transverse waves have, both types of wave have vibrations, both types of wave transfer energy. The difference is in the relative direction of those two things. So in transverse waves, the direction of energy transfer is perpendicular to the vibrations. In longitudinal waves, the vibrations are parallel to the energy transfer. So I like to remember that longitudinal and parallel both have lots of L's in them. You could also mention that longitudinal waves have compressions and rarefactions. So compressions where the particles in a sound wave are close together, rarefactions where they're spread apart. Then we need an equation linking frequency, wave speed and wavelength. So I'll write that one down. You can get it off the formula sheet in 2022. Wave speed equals frequency times wavelength. Okay, and then I substitute in the numbers I've got. Now these are in standard form. So when you're substituting them in, you can either write them in standard form, so just copy them as they're written, which is the low risk option because you don't risk losing a mark by writing the incorrect number of zeros. Wave speed equals frequency times wavelength, or you could decide to convert them into numbers with zeros after if you prefer. But the calculators they give you in exams should be able to cope with you or the ones you bring with you, even better, should be able to cope with just typing in numbers like this. So frequency equals, we're rearranging this, so the number, it's a times at the moment, so it needs to become a divide. So 3 times 10 to the 8 is on its own on one side of the equals. Might not look like it's on its own, but because it's in standard form, that's all one number. So that goes on top of the division. 3 times 10 to the 8 is just 3 with 8 zeros after it. So just so you know how to convert. Again, it's safer to write this down, copying it out in standard form. And then 4 times 10 to the 9 would be 4 with 9 zeros. Since it's got 0.8, it's 4, and then an 8 replaces one of the zeros, and then you've got 8 more zeros. Okay, so that's what that looks like. Okay, now you could then cancel the zeros, so knock 6 zeros off, knock 2 zeros off, we get 3 divided by 48. You could also have done that by doing 10 to the 8 cancelled out of this, so this becomes 3 divided by 4.8 times 10 to the 1, which is 48. And that works. Sorry, they've given us the frequency. This should be times wavelength. Doesn't affect the rearranging, but just shows how easy it is to make silly mistakes in exams and how carefully you need to double check things. 0.063 meters is my final answer for the wavelength. And I have rounded that to 2 significant figures as I've been asked to do. So don't forget to do that. When you're checking exams, retype things into calculators to check you haven't made a silly mistake. Look, somewhere on the paper it will have asked you to round to 2 significant figures. Somewhere on the paper it will have asked you for a unit. Make sure you haven't missed those and type your rearranged type this back into the equation. So type into your calculator 4.8 times 10 to the 9 times 0.063. Check you get 3 times 10 to the 8. Then we have the final part of this question. Describe how the radio waves reaching the car aerial produce signals in the electrical circuit of the car radio. So, the car aerial absorbs the radio waves. Those radio waves then cause electrons in the aerial to vibrate. Vibrating electrons is an alternating current, so we've produced an alternating current, and that frequency of the alternating current is the same as the frequency of the radio wave. So any 3 of those 4 points would get you a mark.